In this section of Chapter 9, we are going to talk a little bit about solution preparation, do a little review, and then talk about dilution. How we prepare the solution from solid is we weigh the solute accurately with an analytical scale. We transfer it to a volumetric flask, and then we add water to the flask up until the actual amount, the volume that we need. Then we swirl to dissolve the solute. We can add more water to bring the volume up to where we need it. Then we cap and invert to assure that the mixing is uniform throughout the solution and it has the same composition. Here is a sample problem that contains a little bit of review. Okay. We have an aqueous solution of glucose with a molar mass of 180.2 grams. Determine the molarity of a 2-liter solution that contains this much glucose. Remember, molarity is given as moles of my solute per liters of solution. Then I need to calculate the volume that would contain 0.25 moles of glucose. Once I calculated the molarity from up here, then I can use that molarity and the moles of glucose to calculate the volume in part B. Then the number of moles of glucose in 0.5 liters of the solution. I will use the same molarity from part A and the volume in part C to calculate the number of moles. A lot of times in laboratory, we use concentrated solutions, and then which we call stock solutions. Then we prepare dilute solutions from those stock solutions to use in experiments or in labs for students. It wouldn't be very practical to use dilute solutions because we may need a lot of dilute solutions and we don't have storage space. And so we always use concentrated solutions and then just use the dilution formula that we're going to talk about to get the right concentrations. So we measure a precise volume using a volumetric pipette, and we transfer it to a volumetric flask. Then we add water to this flask to bring the volume to the mark on the flask's neck where it needs to be. Once again, we cap the flask and invert it to make sure that there's a constant composition throughout the solution. But this is the formula that we're going to use to go from concentrated to diluted. The molarity of my concentrated solution times the volume of my concentrated solution is equal to the molarity of my dilute solution times the volume of the dilute solution. You will know 3 out of 4 variables, and then you will be asked to calculate the 4th. For a lot of these types of problems, the most difficult part will be to determine what am I given? Is it my concentrated or is it my diluted information? Let's take a look here. What volume of 12 molar HCl, which is a common laboratory stock solution, must be used to prepare 250 milliliters of 0.125 molar HCl? What am I given here? Well, I have the concentration, molarity of my concentrated solution. So I have MC. I also have the volume of my diluted solution, which is LD, and I have the molarity of the diluted solution over here as well. And I'm asked to figure out the liters or the volume of the concentrated solution. So what can I do here is 12 molar times the milliliter of the concentrated solution is equal to 0.125 molar times 250 milliliters of the dilute solution. Note that I put the milliliters over here because I could have converted this to liters and calculated this in liters, but it doesn't really specify whether it should be in liters or milliliters. And so since this was already in milliliters, I left this one as well. Make sure that these match, however. So if this is in liters, so will this as well. But if this is in milliliters, then I can solve for this in milliliters and it's fine, unless I'm specifically asked to figure it out in liters. Then I can isolate my unknown. 0.125 molar times 250 milliliters divided by 12 molar. Molarity cancels, leaving me with milliliters. And if I do this calculation, I should get 2.6 milliliters. So what I need to do is take a 250 milliliter flask, volumetric flask, so pipette out 2.6 milliliters of 12 molar solution, put it in there, and then fill up the rest of the flask, 250 milliliter flask, up to that line where it says 250 milliliters with water, cap it, and make sure that it is uniformly, so invert it, make sure that it is uniformly distributed, and then I went from 12 molar solution to a 0.125 molar solution of HCl. Now here's a problem for you to try. What volume of 6 molar H2SO4 is needed to prepare 500 milliliters of a solution that is 0.25 molar of or in H2SO4? Use the previous problem, the example that was given to you, to solve for this one.